Hey guys, welcome back to AMC 10B 2022, problem 14. Suppose that S is a subset of 1, 2, 3, 25, such that the sum of any two not necessarily distinct elements of S is never an element of S. What is the maximum number of elements S may contain? This one's really tricky, and I got stuck on this for a while. I probably took the longest so far with this problem. Um, I basically my method was to start trying to create a set that would work. And I started by putting one and then two. And then that meant that I couldn't put three because one plus two is three. And then I could put four, but then that meant I couldn't put five or six because four plus one is five, four plus two is six. So it kind of, and then using that, but the problem was I wasn't getting numbers even close to these numbers. So obviously I knew something was off. And then I realized that um, I forgot this part here, the part that says not necessarily distinct. I was ignoring that part when I was doing the problem. And what that means is that you cannot have the sum of a number and itself. So when I was putting in one, for example, I actually can't put two because one plus one is two. Then I can put three, but then I cannot put six. And I cannot put four because three plus three is six and one plus three is four. But then I noticed, well, I can put five, right? Because there's nothing so far that wouldn't allow me to put five. Because since so far I've only put odd numbers, the sum of any two odds is going to be even, right? So there's no reason why I can't. If I start by adding an odd number, there's no reason why I could never put another odd number, because as long as I don't add any evens to the set, then there's no reason why I could never add another odd number. Sorry, I know this is a little confusing, but essentially what I'm saying is if I put one in the set and then I don't put two, actually I can't put two because one plus one is two. Well, then I can put three, and then I'm always going to be able to put five, so adding any odd numbers, right? Because the only way to get an odd is the only way to sum two numbers to get an odd is if I add an odd and an even, but I'm not putting any evens in the set. So therefore, I'm allowed to put every odd number into my set, right? So I can put in 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 20, 25 with no problems. And you can easily convince yourself that this meets the requirement because either add any element to itself or add any two of the elements, you're always going to get an even result. And there are no evens in the set. So I can just have the set of all odd numbers from the set. And that gives me 13 numbers. So the answer would be B, 13. So tricky problem, definitely not easy to do in like 2 minutes or 3 minutes, but with enough thought, you can kind of figure this out. It basically was essentially saying all the odd numbers. It came down to the fact of remembering that the sum of two odds is always even. So therefore, you just don't put any even numbers in the set. So yeah, tricky problem, but fun. I like problems like this because they're problems where you really have to think logically. So, all right, give me any thoughts in the comments, or you did it a different way. Would love to hear your thoughts. Okay, I'll see you for problem 15.